Okay, so we are going to do a bit of work in the Cartesian plane, right? And I want you to just observe the following here. That when we draw our Cartesian plane with our vertical line and our horizontal line, right? We obviously have straight lines, and so this angle here would be 0 degrees. Let me just cover that a little more. And then this angle here would be 90 degrees, right? Because of this 90 down there. And then we add another 90 and we get to 180. And then we add another 90 and we get to 270. And then we end up all the way back where we started, and that's how we get to the 360. Okay? And so we now have all these angles, right? And for all our trig ratios, for certain angles they will have a certain sign. Now I just want you to remember this. We will talk about it more in the following term, but all the trig ratios are positive in quadrant 1, right? The first quadrant. Only sine will be positive in quadrant 2. So the angles between 90 and 180, sine is the only one that will be positive, okay? And then in quadrant number 3, which is from 180 to 270, only tangent is positive in this quadrant, right? So tan of 181 up to tan of 269 will be positive, but sine and cos won't be positive for those angles, okay? And then in quadrant 4, cos will be positive, only cos, okay? So again, quadrant 1, everybody's positive. Quadrant 2, it's sine. Quadrant 3, it's tan. And quadrant 4, it's cosine, alright? And so you can remember this by calling it a cast diagram as seen here. So cos is positive, all are positive, sine is positive, tan is positive in that specific quadrant. You could also remember it as all stations to Cape Town, if you prefer that. Alright, and so we need to remember where the following, or where our trig ratios will be positive, okay, because eventually we have to start drawing rats in these quadrants, and you need to know which quadrant your sketch belongs in, okay? And so we will now look at the example associated with this, right? So let's have a look at that. Okay, so here is the first example in this series of working inside our Cartesian plane, okay? And they tell us that without using a calculator, my favorite phrase, use the figure to calculate OP, which is of course the line over there. Use it to calculate tan A, cos A, and then sine squared A minus cos squared A. Now of course we know for our trig ratios we need to have certain values. We need to either have adjacent, hypotenuse, or the opposite side, and so we need to remember our acronym, so KTOA. Okay? Without this it becomes very difficult to remember which sides go with which ratio. Fine. So now we have of course the point in our quadrant number 2, okay? And as you see this Cartesian plane, your first move or your first instinct should be to go ahead and fill in the all stations to Cape Town, okay? So we would go all stations to Cape Town. Okay, so there where our figure is drawn or our line is drawn, only sine will be positive. Tan and cosine are negative, so whatever values we get over here, they need to give us negative answers because cos and tan are not positive in those quadrants, okay? So they give us point P, which is negative 2 and 3. You need to remember that this is your x coordinate and this is your y coordinate. So this minus 2 is of course over here on your x-axis, and that positive 3 is over here on your y-axis. And so this side over here, alright, has a length of minus 2, and this line over here, right, which is directly opposite the y-axis, is 3. So now you have a complete rat where you have the minus 2 and you have the 3. Okay, at this point we can find the length of OP using the theorem of Pythagoras, which I'm going to write down. Okay, so I wrote down that OP squared will be 3 squared plus the negative 2 squared, and I wrote here P theorem, but of course you need to write out Pythagoras. I just didn't have the space to do so. And then we calculate OP squared to be 13, and so therefore OP, or the length of OP, is the square root of 13. Now I'm going to go ahead and fill that information in because I might need it later. So this here is the square root of 13. Now at this point your rack is completely filled in, it is complete, and so you can find any trig ratios that is asked of you. And so the first one is for us to get tangent of A. Okay, so if you have a look, A is this angle here, right? But when we work it out, we look at it as though A is over there. Okay, so they want tangent of A. Tan goes with opposite over adjacent as per our acronym, and so therefore tangent of angle A is going to be opposite over adjacent, which according to our triangle is 3 over negative 2. So there is our opposite side and here is our adjacent side, and so tan of A is negative 3 over 2, and in the beginning we predicted that this will be negative because tangent is not positive in this quadrant. The next one is cosine of A, so we go cosine of A. Okay, our acronym tells us that cosine goes with adjacent over hypotenuse, so we start there, we say A over H, and in our case our adjacent is negative 2 over our hypotenuse, which was the square root of 13. And again, just as predicted, cosine should be negative because cosine is negative in that quadrant. So now finally we need to find sine squared A minus cos squared A. Important to remember, and as I wrote down, we find the sine of A and then we square it, then we subtract cosine of A and then we square that. Now I'm going to fill in cosine of A because we already have it. So cosine of A was found to be negative 2 over the square root of 13. Okay, and now we just find cosine of A. Sine goes with opposite over hypotenuse, and so the opposite here is the 3, right? The opposite side is 3 and the hypotenuse is the square root of 13, right? Now once you type this in your calculator, you should get an answer of 5 over 3. Okay, please be extremely careful when you type it in. You need to make sure that bracket is covering your entire fraction, okay, otherwise your answer might be affected. And so this is how we work in the Cartesian plane. But I would like us to make a short summary of what we did, right? So what we have done up to this point, right? We noticed that we had a Cartesian plane. Okay, I'm going to try and do this nicely. We had a Cartesian plane, and then we first filled in the lengths, right? We filled in the length on the x-axis and we filled in the length on the y-axis, right? After we filled in the lengths, we went ahead and we found missing sides using Pythagoras, right? So we went ahead and we found the hypotenuse using the theorem of Pythagoras, and once we did that, we were able to apply that knowledge and find different trig ratios. Okay, so once you have a point in the Cartesian plane, you need to first fill in the lengths. Okay, I'm going to do it again. So they gave us the 2 and the 3. I'm going to use a rainbow color. They give us the minus 2 and the 3. The minus 2 goes with the x-axis, so that is over here. Minus 2. The 3 goes with the y-axis, so that is over here, right? But we want to just get the length opposite. So if this side here is 3, then this is also 3. So that is what I meant by fill in the lengths. Then we did Pythagoras, and we found that the hypotenuse here is the square root of 13. And once your rack is complete, you can answer any questions that they ask you because you have all the sides that you would need. Okay, I hope that this was easy to understand, and we will do another example. Thank you so much for watching.